Welcome to Study Loop.
So for this example, we're given a vector equation and we need to prove the following statement. So in order to prove this statement, we need to massage our vector equation to get it in the right form necessary to prove that statement. So we know that r would be equal to the magnitude of the vector equation. Therefore, r would be the square root of x squared plus y squared plus z squared. Okay, and we need to prove this statement. So now we have an expression for r. So therefore, del of 1 over r is equal to, so it'd be d dx of 1 over r I plus d dy of 1 over r plus d dz 1 over r. Okay. Now we just need to find our partial derivatives. So d dx, d dy, and d dz. Okay, so therefore d dx is equal to of 1 over r is equal to minus 1 over r squared dr dx, and partial with respect to y will of course be the same thing, except we have this other derivative that we have to find, and d dz of 1 over r is equal to minus 1 over r squared dr dz. Okay, so now we have the necessary components to put into our expression. So therefore we can say that del of 1 over r is equal to, and since all of the terms have a 1 over minus r squared, then we can just factor that out, and that just becomes 1 minus 1 over r squared of dr dx I plus dr dy j plus dr dz k. Okay, so now we just need to find these partial derivatives. Okay, so we know that r is equal to square root of x squared plus y squared plus z squared. So therefore, dr dx is equal to the derivative of this, so that's x squared plus y squared plus z squared to the 1/2 power, which is equal to 2x over 2 times square root of x squared plus y squared plus z squared. Okay, 2's are going to cancel, and of course this is just equal to r, so then we can say that dr dx is equal to x over r. And this is going to be the same derivative just carried out with respect to different variables. So then we'll find that, so dr dy is just equal to y over r, and dr dz is just z over r. Okay, so now we need to put these derivatives that we found back into our expression. Okay, so that will give us, so del of 1 over r is equal to minus 1 over r squared. So we got x over r plus y over r plus z over r. Okay, so now they all have a common factor of r. So let's just bring that out, and then that'll give us del of 1 over r is equal to minus 1 over r cubed, xi plus yj plus zk. Okay, well, we actually already have an expression for this. If you recall that this is equal to r. So, therefore, we can say that del of 1 over r is equal to minus r over r cubed. Hence proved.